We have seen the introduction of our subject, engineering geology subject. Then we have also discussed about the various branches of engineering geologies. Then we have also discussed about the how the subject engineering geology is came into picture. Then we have also discussed about the what is the scope of this engineering geology subject. It's what is the application of this engineering geology. Then we have also seen about what are the planets in our solar systems, and there are a total 8 planets, inner planets and outer planets. We have also discussed about the densities of these planets, then compositions of these inner planets and outer planets, then the rate of rotation of planets, and then we have also discussed about the theories which represents the origin of earth. Basically these are two theories, evolutionary theory and catastrophic theory, and based on to support this theory there are different hypotheses. We have seen these different hypotheses, and then we have also seen the age of the earth. There are different methods which are used to calculate the age of the earth, and basically currently we are using radiometric dating method. Before that there are different methods which were used to calculate the age of earth. These methods are history of organic evaluation, then rate of sedimentation, salinity of seawater, and rate of cooling. So one by one we have seen these methods, basic general information of these methods. Then today we will see the interior of earth. So first of all, as we can think about the interior of earth, then first question arises in our mind that how this interior of earth has been calculated. So it has been calculated based on the passage of different seismic waves. As we know, the seismic wave can be partly reflected and its velocity get also changed while passing from one zone to another zone. Okay, so based on this data of refracting the seismic wave and changing its velocity, different zone has been defined. Different zones of the earth has been defined. Interior of the earth has been defined, and it has been considered that this seismic wave travel with different velocity from the different earth crust. Okay, then based on this the data, the location of different layer has been finalized, and the composition of this different layer has been also determined. Then based on this we found that the total whole earth has been divided into mainly 4 zones. First zone is earth crust, that is surface part of the earth. Okay, second zone is mantle zone. First one is crust zone, second zone is mantle zone, third zone this is outer core zone and inner core zone. Okay, so this is outer core, inner core, outer core, this is mantle zone, and this is earth crust. Okay, so first of all we will see the earth crust. Okay, it is the outer superficial layer is called earth crust. This is outer superficial layer is called as earth crust. This earth crust is having the thickness of 30 to 40 kilometer. Okay, thickness of this earth crust is 30 to 40 kilometer. Then 30 to 40 kilometer below continent. Continents means the we can say that where the land is available, these are the continents. Okay, so below these continents the earth crust having thickness of 30 to 40 kilometers, and below the ocean where the land is not available, there is only ocean water. Okay, so below this ocean water the earth crust thickness is only 10 kilometer. Okay, so at the bottom of earth crust it is assumed that the velocity is increases based on the data available, data of seismic velocity availability. Then as it is supposed that at the bottom of earth crust the velocity increases as the waves transfer from the earth crust to the mantle zone. Okay, and mantle zone is more denser than the earth crust zone. Okay, and the boundary between earth crust and the mantle zone. Okay, so this is mantle, sorry, this is earth crust and this is mantle. So the boundary between earth crust and mantle zone is called as Mohorovicis discontinuity. Okay, is called as Mohorovicis discontinuity. Okay, so this earth crust is divided into two layers. Okay, so earth crust is divided into two layers, so top layer and bottom layer. So top layer is less dense, having specific gravity of 2.65, and the bottom layer is denser than top layer, which is having the specific gravity of 3. Okay, okay, so top and bottom layer less dense and denser zone. Then this less denser zone of having specific gravity of 2.65 is called as SIAL, SIAL. Basically granite, it is found in this top layer. Okay, and this SIAL, meaning of this SIAL is the rock rich in silicon and alumina. Okay, where in this SIAL layer we found the rock which is rich in silica and alumina, whereas in CIMA layer is the denser zone, that is lower zone, we can show that lower zone of earth crust, CIMA layer. So it is the which is having specific gravity of 3. It is the rock rich in silica and magnesia. Okay, then under ocean only CIMA layer is found. Okay, as CIMA layer is means denser zone is found, as the less denser zone, that is SIAL layer, is absent under ocean. Okay, so this is about the earth crust. Now we'll see the mantle. Okay, so mantle is having the thickness, mantle means the zone which is lower than the earth crust zone, which is mantle, which is having the total thickness of 2900 kilometer. Okay, so this mantle is divided into two layers, so upper mantle and lower mantle. Okay, so it is located at the below the earth crust. Then the upper mantle and lower mantle, the boundary between this upper mantle is lower mantle is around 700 kilometer. Okay, so in upper mantle there is a ultra basic rock which is called as peridotite, which is having the average mineral composition of lava. Okay, with the density of 4.3 into 10 to the power 3 kg per meter cube, which is again contains anthosphere. Okay, up to 550 to 100 kilometer. Then this is anthosphere, and the outer portion of this anthosphere is called as lithosphere. It is this lithosphere is a combination of upper mantle portion and some part of earth crust. Okay, so some part of earth crust and upper mantle portion is lithosphere. Okay, and the lower mantle, which is higher denser, which is having the higher density minerals and with the density of 5.5 into 10 to the power 3 kg per meter cube, whereas for upper mantle the density is 4.3 into 10 to the power 3 kg per meter cube. Okay, now we will see the core portion. See, at the central portion, this central portion is nothing but the core portion. Okay, as you can see the earth crust top portion, then upper mantle, then lower mantle, then outer core and inner core. Okay, so the boundary between this earth core and mantle is around 2900 kilometer. Okay, so now this core portion is very denser, as the S wave, seismic wave, could not pass through core portion. Okay, and it is considered that this earth core portion contains some solid and liquid portion. Okay, and it is again divided into two parts, outer core and inner core. So outer core is having the inner core is having the radius of 5150 kilometer. Okay, and density of 1.2 into 10 to the power 3 kg per meter cube. Okay, and again it is consist of iron, nickel and similar minerals, similar materials to the meteoroids. Okay, this is meteoroids. Okay, ठीक है. So today we have seen the internal structure of earth, in which we have discussed about the earth crust, then we have also seen the mantle. Okay, then we have seen the core portion. Okay, and next we will see the basic theory of continental drift. Okay, ठीक, thank you.